Alright guys, today we're going to talk about the elasticity of the demand. So let's figure out firstly what it is. So the elasticity of a certain product, let's just call it E at the moment. We're not going to say a function of what it is, but just the elasticity will be how much the demand is going to change. So the change in the demand, let's call it capital Q, with respect to, well, Q, I should have done capital Q, but that's okay. So the percentual change of the demand versus the percentual change of the price. Let's think about that one as capital Q. I don't want to erase. But for example, if you had that a product if the price goes up by a 10%, then let's say that the demand decreases by 20%, then the elasticity of that product or that commodity would be 2. Meaning when this is larger than 1, the price is elastic. So meaning that the price, the change in price gave you a change in demand that is higher than 1. So this quantity, this percent was larger than this one. So an increment of the elasticity means that an increment in price will trigger a large decrease in the demand. By the way, I put this one as positive, meaning that my demand decreased. But that'll be clearer when we write the formula in terms of the derivatives. Now, a product, on the other hand, that if you increase the price by 10%, the demand only decreases by a 1%. Has an elasticity of 0.1 that is less than 1. So this is going to be called inelastic. Meaning that the price doesn't, the increment in price do not trigger a big change in the demand. So examples of products that will be elastic will be luxury goods. So for example, if the price of an iPhone gets too expensive, at some point you don't buy it. Or if the price of the TV gets too expensive, then you don't buy it, or an item of clothing. So those are examples of products or commodities that would be elastic. Now, inelastic is, for example, energy. Like if your bill, your electric bill increases, it would have to increase a lot for you to start changing your thermostat much higher, right? You tend to value that comfort. There's things you really just cannot do away with, like your refrigerator or your stove, and if it's electric in that case. So there are things that you just cannot stop consuming. Now, gas is a very interesting commodity because in general, it is inelastic, meaning that prices go up, you're still going to travel, you're still going to go to work, you're still going to do the things that you wanted to do. However, in a local sense, if you have 2 gas stations and one is much cheaper than the other, then the demand in the more expensive one will decrease because the competition will cause that particular brand of gas, if you will, or that location. At that point, if there's a lot of competition, then the price becomes elastic, or the commodities rather becomes elastic. But in general, energy and gas are inelastic commodities, so examples of those, because you're going to need them. One very good example of an inelastic commodity is salt. You're going to cook with salt regardless of what the price is. I guess in antiquity, perhaps not, where they would say that you're worth your weight in salt because it's so expensive. Anyways, but this is the formula for the elasticity, and that's what it's telling us. So let's try to look at it a little bit further in terms of calculus and see how we can make this a little bit more computable for us. Let me erase this. I'm going to just keep this and I'll give a little bit more detail. I'll be right back. All right, so we're going to derive the formula for the point elasticity. So that's going to be the one where we're going to use the derivative, which is of interest for us. Now, let's try to start from this point. So let's think about that if we had the change in the demand versus the change in price, and then we multiply times price, that is a function of Q. I did lowercase q again. Well, that's capital Q. I apparently don't have a good functioning lowercase and uppercase in this video. Anyway, so now if you look at the delta as delta P goes to 0, the only thing that we have to think about, this is going to become the derivative, or this is going to go to the derivative of Q with respect to the price, and then price as a function of Q, and the book will say Q naught over Q. And then the one thing I wanted to mention is there will be a negative that will pop out, because usually we think about this delta as we make it positive automatically, because we say that as price increases, our demand will decrease. So we just said a 10% increase in price will trigger a 20% decrease in our demand. But since it's decreased and we're talking about derivatives, this should be a negative. So that's the only thing that we have to remember. That's going to be negative the derivative. So with respect to the price, and then multiply times the price divided by Q. All right, so I had written an example, but I didn't quite like the way I explained it. So let me do it again. So let's say that we have a demand curve that depends on the price. So we usually call this one Q. The book I used to use before, we would call it D. Let's say that the demand curve is given as the why am I blanking? The demand with respect to the price, the square root of 900 minus 20x. Something like that. And if you draw that, you have to figure out your intercepts first. Let me use some thicker marker for that graph. This one's kind of looking a little pale. When x is equal to 0, this goes away. Square root of 900, you get 30. So that would be the demand when the price is 0. So when you want to give it away, you can only give 30 of them away. But then when the price, when would the demand be absolutely 0? Well, if the demand is 0, you have to set is equal to 0. You get 900 is equal to 20x. From where you divide, you get something like 45. When you solve it, you can solve it. It would get 20x equals 900 divided by 20. This is going to be 45. And so your curve is a square root, sort of, that looks sort of like this. Like that. And so that is your curve right there. And of course, in our course, you would plot it using Excel so you can visualize it. And so let's figure out what would the elasticity be at something like 30. What would that be when you have 30? That would be the square root of 300, which is square root of 3, 1.6 something. So 100, so 16, sorry. Yeah, going to 16.9. So not quite drawn to scale, obviously. But so we are interested in finding what would be the elasticity of the demand. So let's move over here and let's try to compute things. So it seems like I need the derivative of Q with respect to P. And this is where when in the previous example, I didn't calculate the details. And I figured that it was not very nice to do. So to compute the derivative of this function, what you would want to do is firstly, that's the easiest way to do it, or to see what to do, is write it as a power of 1/2. When you do that, you have to drop the 1/2. This marker is also pretty pale. Let me get another one. Let's try this one. I don't know, not that much better. All right, so you're gonna be dropping the 1/2, copying the inside, and then raising it to the power of 1/2 minus 1, which is negative 1/2. But you're not done. remember that for chain rule, because you're doing a chain rule, right? You don't have x inside the parentheses. You have 900 minus 20x. You have to multiply times and I forgot a negative when I copied my function here. When you take your derivative, you get the derivative of the inside, which is going to be a negative 20. So notice that the negative 20 and the 1/2 will cancel. It's going to give you a negative 10. And then you're going to have the square root. You can drop it to the bottom. This is square root, but with negative exponent, you can drop it down here. All right, so I need the negative derivative here. But I need it at p equals to 35. That's what we agreed on. We're going to compute it, or 30 rather. So we said that we wanted to find the elasticity at 30. For what reason? I don't know, but that's where we want to find it. So we need to evaluate our derivative at price equals to 30. By the way, I changed all the x's for prices, as you can see, but it should have been price. So you plug here at your price of 30, as we evaluated before, was going to be the square root of 300, which is going to be here, square root of 300. You can write it as 10 times square root of 3. If you don't mind, we can avoid having to rewrite everything. And when I plug it for this one right here, I get the negative of the negative, 10s cancel, and I get just 1 over the square root of 3 for this. Now I need the price that we said was 30. And now I need the quantity Q, or the demand Q, at 30 as well, which is yet another one of those 10 square root of 3. When you evaluate it, we did it here. I should have written it, but it's the same thing. So it's quite nice, my example, because I actually get the elasticity to be 1. These 2 square roots of 3 give me a 3. 3 times 10, 30. And I get an elasticity of 1. And wow, that's luck right there. And what does that mean? That means when you have an elasticity of 1, is a perfect correlation. So an increment of 10% will give you a decrease in the demand, or a 10% increase in price will give you a drop in the demand of 10%. So it's a 1-to-1 correspondence. What are the odds that you just write a random example and you end up with an elasticity of 1? That's too much luck. All right, well, that was a great example. Now, if the elasticity would be greater than 1, what that tells me is that this price would be quite elastic, meaning that if you increase the price by a certain percentage, your demand would decrease by a higher or larger percentage. And again, if the elasticity happens to be less than 1, then you're talking about a commodity that is inelastic. Now, if you have a commodity that is elastic, then what can happen is, well, you got to be a little bit more mindful or more careful of increasing prices, because you may drop your demand by a lot. But if you have a commodity that's inelastic, then you can get a way to increase revenue with increasing your prices a little bit, because your revenue, your demand will not drop at the same rate. So by increasing prices, you'll get more revenue. On the other hand, if you have an elasticity higher than 1, then if you would increase prices, then you would decrease your demand, so it would be a problem. So you may want to decrease your prices a little bit. Right here, don't touch it, you're good. All right, we'll wrap it up here. I have like 2 versions of the video I'll have to put together. So I think it's going to be a good one. But thank you for watching, and I'll see you in the next one.